Hello student, welcome to our physics discussion that is physics in a smart way. In some of our last lecture we are talking of thermodynamic work and all that, and also we did conclude that one of the ways to find the thermodynamic work, if by chance you got or we got the pressure volume graph available of the process, so thereby work can be taken as the area below the pressure volume work. The process that is given, you can go through the question. The process that is given is known as a cyclic process. A cyclic process has start and finish at the same time, that goes through in a circular way, not exactly circular, in a roundabout way. It can be circle, it can be ellipse, it can be very odd figure like this, but start and finish, they have to be the same thing. Okay, so then it's known as a cyclic process. It may be a cyclic process, but still then it has to obey all our ideas that we have developed for thermodynamic work. And for a cyclic process, with a bit of thinking, for a cycle, if you try to think, you can pause the video here, you can try to think, you can try to work out, it's okay. Otherwise, in some of our videos, I'll be explaining, I'll be going to that cyclic process. And work done in a cyclic process, work done in a cyclic process or work done in a cycle, it's same as enclosed area, is same as enclosed area. Enclosed area. So thereby we know our enclosed area, or because the cycle, the question says, explicitly mentions that it's a circle, so thereby it's a circular area, or it's an area which is like this as I am showing you. And for a circular area, you know area must be equal to, for a circle, that is pi r square. So here work done must be, a student can find out like this. If he considers pi means 3.14 into r square, so thereby he or she can say that is pi into the student can think like this, because the area is pi r square. If he or she takes a radius in terms of volume, we know the spread of the volume is from 0.2 to 0.8. 0.8 minus 0.2 is 0.6, and that's the diameter, and half of that's the radius. So thereby a student can say that is 0.3, that is 0.3 square of that. Obviously unit will be in joules. A second student can also find work, that is using the same formula, that is pi r square. Pi is pi 3.14. You know, if a student emphasizes the pressure and tries to find the pressure, we know the pressure spread is from lowest pressure is 3 into 10 to the power 5, highest pressure is 5 into 10 to the power 5. The difference of them is 5 into 10 to the power 5 minus 3 into 10 to the power 5, that is 2 into 10 to the power 5, that is the diameter, and radius of that will be equal to 10 to the power 5. So a student can say pi r square, and because r comes out to be 10 to the power 5, so the student puts in like this square. A third student, if he or she is a bit confused and go for a social solution, or go for a, what we may say, we got democratic system, we got socialistic solution, that is like this. So he or she thinks like this, because area equal to pi r square, he or she thinks like this. If I consider radius along the along the volume, then radius comes out to be 0.3. If I consider radius, sorry, just a minute, my pen is malfunctioning. If I consider radius along the pressure, so that will be coming out as 10 to the 5. So pi r square here she thinks in a socialistic way, pi r square equal to pi into r. So why quarrel? Why don't give one r to volume or the r to radius? So three different formulas and three different values of work will be coming in. You can clearly see the values will be different. So which one you have to consider as the correct answer and which one is correct? You have to find out. That is the puzzle for you. But one thing I may give you a hint. Have you heard the term known as scale issues? Scale issues, whenever we are considering a map or graph or something that, sometimes this issue comes in. So have you heard of the term that is scale issues? Try to think on this. It's not so difficult. And I hope you'll be getting the solution. If not, I'll be giving you at the end. Okay, so that's all for today. Thank you for your kind cooperation. Please share, please like, and please subscribe. Of course, I don't want to repeat all those boring things at the end. But you know. Thank you.